Hello, let's have a look at how a university question in the DH convention generally is asked. So here we are having a question from Kerala Technological University, KTU. It's an April 2018 question paper. The sixth question having 8 marks, part A. For a simple two-axis robot shown in the figure, so what they mean by two axis here is that they have not drawn the third axis for it. For a simple two-axis robot shown in figure, assign appropriate frames for DH representation. Second, fill out parameter table. Third, derive the forward kinematic equations for the robot. So they have given the robot, they have given the various length that is there involved in the robot. They have also given theta 1 and theta 2, which are basically the joint variables. So there are two kinds of joint here. One is this first joint, which it's actually a revolute joint. The second one is also a revolute joint. The third that they have shown is basically the end effector portion, which they have referred to as H. Maybe it means hand. Now, even though they have written assigned appropriate frames for DH representation, actually the frames is already drawn. So actually only second and third is what is required to be done. But if suppose we would have got without any of these, then how would we have come up even with these frames, and how will we do it? We'll have to look at by doing the question. So what I have done is I have drawn a similar robot, the two-axis robot. I'm going to draw the frames here based on the DH convention that we have studied, and we are going to find out the link parameter table. So before that, let me complete what is the required diagram. So here is the robot. So let us start without wasting any time. So now the first thing that we have to draw is we have to draw the axis, the z axis to be precise. First we'll have to draw the z axis. So let me take, yes, so there are two joints. The first joint, the axis z, since it's a revolute joint and the revolute joint is having a movement like this, I will draw the z axis coming outside. So this is the z axis. It is coming outside of the paper, but when we write it, we have to obviously draw it like this in a two-dimensional page. So based on that, this will be z0. Then the second is, again, it's a revolute joint. So I will draw again an axis which is coming out. So that is the axis of the second one, and that is going to be again z1. And here they have already drawn for the third, the end effector, they have given it as h, so I can write it as z2 for the third axis, but since it's already given in the question, I will draw it similarly. Now where should I draw? Should I draw it in the front or should I draw it in the side? Basically we know that the rule is try to follow, for the case of end effector, the z axis exactly as the previous joint. So the previous joint is drawn in this direction, so I will draw for this one again, I will draw it in this direction, which is parallel to z1. So this now becomes zh. Now based on that, we have to find out what is the x-axis. Now we already know that x-axis is basically given by, if you are having two axes, I have always said that I always go for the x1 first. So if I have to draw x1 is basically based on z1 and z0. Here z1 and z0 are parallel, both are coming out of the paper. So I can draw it anywhere. So if you look at the diagram, it is drawn in the same direction as the direction of the common normal between them. So I am also going to follow the same. That is what we can do. So this is the direction of the common normal, and that is where we are going to draw our x1. Then obviously x0 can also be in the same direction, so I can draw in the same direction. Here if you would see, they have drawn the x0 in a different direction, but we can draw in the same direction. It does not matter. Here they have not mentioned exactly in which angle it is kept. So what I would suggest is we draw it exactly as x1. I will draw it in this. Don't worry that its value is going to be somewhat different, because here it is drawn like in this direction. Don't worry about that, because they have not mentioned any angle specifically at which it is drawn, so it can be taken as if it is similar to x1. So here I will write this is going to be my x0, and then similarly z1 and zh are parallel to each other. So again, the x-axis should be in the direction of the common normal connecting, and the common normal connecting between them is already drawn. So this is going to be my xh. Why I drew? Because this is that the dotted line is a common normal between z1 and zh, and here the common normal between z0 and z1 was this dotted line. Okay, so now the frame is completed. Now what is remaining is that we write the link parameter table. Now for the link parameter table, we are having 3 frames, so we will have 2 rows. So I will have I is equal to 1, which is basically going from frame 0 to frame 1. Then the second row will be for going from frame 1 to frame h. So first theta is the angle with which we have to rotate so that x0 becomes parallel to x1. Here both of them are parallel, so it will be no angle movement, but there is theta 1, which is the joint variable. So I will write here theta 1 star. Basically it's a joint variable. See, if this angle they would have given, as that this is 45 degrees, and I know that okay, that x2 and x0 are 45 degree apart from each other, then for this, instead of writing theta 1, I would have written theta 45 degrees plus theta 1 variable. But since there is no angle given here, so I cannot guess that it is 45. I cannot write a new angle there. What I will have to guess is that x0 is actually in the direction of the common normal as the one in the front, so x1 in the same direction. That's why in our case I have drawn it in this direction. Now based on this, if I am going to write the second value, so let me take the pen. Yes, so what is d1? D1 is to make x0 and x1 collinear. They are already collinear, so I don't have any value to be taken, so this will be d1 will be 0. Next is ai, which is basically the movement in x direction, so that x0 becomes overlapping with x1 and both the origins meet, and here it is already written that the length is a1, the length of the link is a1, so that is the distance that x0 has to travel so that it overlaps with x1. So I will write here as a1. Now I am not putting a star here because it's not a variable. The link length is fixed, it's not variable, so it's a rigid body, so the length is fixed, it's a1. That's why I'm not putting a star here. Next is, once I do that, you can already see that z0 and z1 will overlap, so there is no alpha, there is no twist angle, so it is 0. Now for the second case, I will go from frame 1 to frame h. Here again, as you can see, there is no angle specified, only theta 2 is the variable, so I will write theta 2 star. Then what is the distance to be moved in z direction, so that both are collinear, both of them will be collinear with theta 2, so di is going to be 0. The second one will be what should be the movement in x direction, so that x1 and xh overlap, that will be a2, and since z1 and zh are already in the same direction, this is going to be 0. So the link parameter table is done. So you can say that based on this, I can write the answer as, the answer will be, so let me take a different pen. Okay, so the answer has first part, which is the frame diagram. The second part, which we have just now done, is the link parameter table. So first and second is done. Now we have to look at the third question, derive the forward kinematic equations. That means we have to find out a1, a2, and then multiply it. So we have to look at the equation that we take for it. So this is the equation that we use for writing the transformation matrix for each row of the link parameter table. So without wasting time, we will straight away go and write the equation for a1. So as we already know, we have to put the equations of theta, alpha, d and a1 here. So in the first row, it is theta 1, so I will write cos theta 1. If you remember, I had already said the shortcut was to write cos theta 1 like this, which we can further write it as c1. So I will basically use that notation. So it is c1 here, then sine theta 1. So I will write sine 1 here, 0, 0. Then we are having alpha is 0, so cos of alpha will be 1. So again I will write here as minus s theta 1 cos theta 1. Then sine of alpha, sine of 0 is 0, so this will be 0, 0. Then the third row, sine of alpha, sine of 0 is basically 0, so it will be 0, 0, and this one will be 1, finally 0. AI is a1, so it will be a1 cos theta 1, a1 sine theta 1. Then di is already 0 and 1. So this is a1. Similarly, I can find out a2. Again, I have to put the values, and based on that I will get this, and you can check it. Now for getting the final transformation matrix connecting 0th frame with the hand, what I will do is, as we all know, it's basically based on the transformation matrix that connects the hand with the 0th frame is given by multiplying the first frame with respect to 0 with the transformation matrix of the hand frame with respect to 1, which is actually our a1 into a2. Here they have not talked anything about the universal frame, so we can rest assured that there is no universal frame. Now the multiplication of this, so it will be slightly lengthy, so let's have a look. So cos, so I can write cos 1 cos 2 cos theta 2 minus sine 1 sine 2 is, yes, let me have a look if I am correct here. Okay, let us do it fresh. Okay, if I'm going to multiply, I will show the step also. What generally I do is I directly write this on top here, so I will get c2 s2 0 0. Now I multiply with each row, I multiply and add, and I write the value here, here, here. So I get the 4 values. But as you can see that these two are already zeros, so whatever you multiply with that, you are already going to get it as 0. So there is no point in multiplying and adding these two. So I will just add these with this. So I will get c1 c2 minus s1 s2. Then second row will be s1 c2 plus C1 S2, which is actually sine theta 1 cos theta 2 plus cos theta 1 sine theta 2, and we can reduce that. We already know the sign conventions and all, so we can write it. We will write it later. And then when you come down, it's all 0, so I will basically write this as 0. Now for the second one, I have to again, write here what is going to be the multiplication factor. So this is the second column. So second column will be minus S2 C2 0 0. So again these zeros are going to multiply and make everything 0, whereas these two are only there. So now I can write them as, so it is going to be minus of C1 S2 plus S1 C2. Okay, and then the second one will be minus of S1 S2 plus C1 C2, and then it's all going to be zeros. And then for the next one, so again I will take out this one and I will try to write what is going to be the row here, which is going to be multiplied, is the third column, so which is going to be 0 0 1 0. So it's all multiplying with 0. Only this particular column is going to be picked up, so directly I can write, so 0 0 1 0. And then finally for the last one, it's going to be a bit lengthy because we are having three values here and it's slightly long, so I can write this is A2 C2, this is A2 S2, this is 0 and this is 1. So now it becomes a little bit lengthy, so let me write it now. So it is going to be A1 C1 C2 minus, sorry, this is A2, so it is A2 C1 C2, and then again there is another A2, so I will take A2 outside common, and minus S1 S2 plus A1 C1. Okay, next is going to be, the next one is going to be for the second row. I can again write, so it is going to be A2 again common, and we are having S1 C2 plus C1 S2 plus A1 S1, and then the next is all going to be multiplied with 0, so it's going to be just 0. The last row is going to be multiplied with again all zeros with only one remaining, so this is going to be 1. So now I have got the matrix completed. This is what is going to my matrix. Now see, I can actually reduce this because I know that cos theta 1, cos theta 1, okay, so I know already that cos theta 1 sine theta 2 plus cos theta 2 sine theta 1 is going to be sine theta 1 plus theta 2. So I will basically write that theta 1 plus theta 2 sine of theta 1 plus theta 2, which can be written as sine 1 2. So sine 1 2 actually means sine of theta 1 plus theta 2. So similarly you are having here, which is cos theta 1, for the first one it is cos theta 1 theta 2, cos theta 1 plus theta 2. This one, the second one, is going to be sine theta 1 plus theta 2. So like that we can write for everything. So without wasting time, I will write that so that we get the final answer. So if I'm going to write it again, so 0 th, which is going to give me the value, is going to be, so the first one is cos theta 1 plus theta 2. So I will write it like this: cos theta 1 plus theta 2. Similarly, the second one is going to be sine theta 1 plus theta 2 followed by two zeros. This one is going to be again sine theta minus of sine theta 1 plus theta 2. This one is going to be so yeah, it is same as the other one, so it is cos theta 1 plus theta 2, 0 0, then we are having 0 0 1 0. The last one is a2 cos of theta 1 plus theta 2, similarly plus a1 c1, similarly a2 c, not c, sine. This is going to be sine of theta 1 plus theta 2 plus a1 sine 1, 0 1. The same thing can be written in very short form, as in short form. So I will write this as C12 S12 0 0 minus S12 C12 0 0 0 0 1 0. The final position will be a2 c12 plus a1 c1 and a2 sine 12 plus a1 c1 with 0 and 1 as the final value, and that finishes the transformation equation. Now, why is this called as the forward transformation, forward kinematic equation? Why do we call it as forward kinematic equation? Because see, the link variables were theta 1 theta 2, and the fixed link values were a1 and a2. Based on that, we have come up with the orientation. So the orientation will be the first 3 by 3 matrix. Let me take a pointer. Okay, so the first 3 by 3 matrix that we are having here will tell us what is the exact orientation going to be, and the last two is going to give us exactly what is going to be the last three elements of the last row. So this is going to give us the position, and as you can see, the position is basically dependent on a1 a2 and theta 1 and theta 2, similarly the orientation. So this is the forward kinematic equation, and that finishes the problem.